Hi, I am Rajendra Kulkarni. Welcome to my channel Programming in C with RSK. In this video, I will be discussing about constants, variables and keywords used in C. While learning a language, whether it's natural or a programming language, we always take care that the communication should be effective. Both the languages, the natural language is a medium of communication, but it is in the real world, for the real world. Programming language is a medium of communication with computer. In both the languages, the only difference is the programming language has to be always used for communication in written form. Programs are written first and then they are compiled and executed and used. The compiled file, the execution file, executable file is used for communication with the PC. When learning C, we follow the same way by which we formally learn natural language. While learning the natural language, we first learn characters, symbols, and the grammar of the language. We understand the importance and meaning of various symbols used for the natural language. In programming language, we learn the characters, symbols and keywords that are recognized by the respective programming languages compiler. We use a lot of constants in the form of numbers when we do our day-to-day business in the real world. A computer programming converts, in programming we convert the real world issues into programs. So naturally, a programming language should have the ability to convert the real world issues into programs which will be run on the computers and which will give us the desired results. So for learning C, we first learn what are the recognizable characters by the C compiler. We also learn there are certain rules by which constants, variables and statements are to be created for our C program. A syntactically correct program will be accepted by the compiler. It will get compiled and converted into a executable file or executable program. Logically correct program will only give the desired results. Compiler never checks the logic used by the programmer in his program. It only checks for whether the program is syntactically correct, whether the symbols, keywords, characters, statements are written in the way they should be written as per the rules of the language. In C, there are characters which are used in natural language, English-like language. It recognizes all the characters of the English language. It recognizes the symbols. It recognizes the digits. It, in characters, it recognizes A to Z in uppercase, A to Z in a lowercase, digits 0 to 9 are recognized as valid digits while writing a program. Then there are around 25 symbols which are being displayed on this slide. These symbols play an important role when a program is getting compiled and executed. Now there are symbols like curly braces, there are symbols like parentheses, square parentheses, the symbol for greater than or lower than, checking, and so on. There are total 32 keywords in C. Some of the examples are int, float, char, unsigned, if, else, for, and so on. All these keywords are listed in the help file of compiler which we are using, or IDE you are using. Understanding the keywords like int, float, char, and unsigned is the learning point in this video. We'll start writing a simple program. It will initiate us to understand better what are the keywords, what is their meaning, how they should be used to create statements using characters, keywords, and certain built-in functions. Our first C program starts with a sentence hash include stdio.h. Then comes void main. Main is a name of the function which is the actual C program. Void is a keyword which means nothing. Void main indicates that main function will not receive anything from other functions. Then opening curly braces. Then come a statement printf in the bracket, welcome to the fascinating world of programming. The whole sentence is written within 2 double quotes. Then the closing parenthesis and a semicolon. Int x semicolon, int a is equal to 10 semicolon, int b is equal to 20 and a semicolon. Then comes the addition statement x is equal to a plus b. In this statement what we are trying to do is adding a and b and assigning the result of addition to a variable x. In C always whatever is the expression on the right side of the is equal to sign or is equal to symbol gets evaluated first, and the evaluation result is assigned to the variable on the left of equal to symbol, which is called a assignment operator in C. Then comes the another statement printf result of execution of above code causes x is equal to %dx, and then the closing braces of the program. What is the output? The output will be, first line of the output will be this sentence which we have, the statement for which we have inserted at the first line of the program, and another output will come out of this statement, printf result of execution. Since 10 plus 20 is 30, x will be assigned with value of 30 by statement x is equal to a plus b, and %d that is appearing here in the printf statement indicates that whatever variable name that is appearing outside the double quotes and after the comma is a int variable. It will contain a value which is of nature int. Int stands for integer. Now header file for printf function stdio.h, it contains the information about the printf statement. Printf is a function, and that function is defined in a file named stdio.h, which is a built-in file. We don't create it, it comes along with the compiler. Every C program starts with main function. After main, the set of open and close parentheses is a must. Opening brace is the entry point of the program. The program, our main program, starts at the braces, opening braces. What printf function does, it displays the text within the quotes on monitor. It just simply dumps whatever is written within the double quotes onto the monitor. It is a sort of output statement. It outputs the result, or it outputs whatever we have written in it within the double quotes. Every statement is terminated with semicolon. It is a must. It acts as a full stop in our natural language. Int is a keyword. A, B and X are names of variables of type int. 10 and 20 are constants of type int. %d is called format specifier. It indicates that the data type of variable appearing outside the double quotes is of type int. For this example, it may be a float. In that case, instead of %d, we will write %f, or if it is a char variable, character type of variable, we write %c. What are the constants, variables and keywords? That we will see in the next slide. You must have observed there is a double slash, after which we are written firstly a plus b is evaluated and then the value is assigned to x. Whatever appears in the line after the slash, double slash, is ignored by the compiler. It is called a statement. It is called a comment. What are constants of type int? In real world, we deal with primary data such as whole numbers, fractional numbers, alphabets in our day-to-day tasks. In C, whole numbers are specified as of type int. Int is a keyword. What is a constant? It is an entity which never changes its value. In our program, earlier program which we have seen just now, 10 and 20 are the constants. How constants are stored in memory? Because as we have known since in our first video, all the program, the complete program has to be available in memory, then only the CPU will execute that program. So whatever we are write in our program, it goes into the memory after it passes the compiler. Compiler converts the English-like language written in our program into a binary language understandable by CPU and the PC. An int constant is allotted 2 bytes in the memory. 2 bytes is 16 bits. Each byte is 8 bits. Who allots this? It is allotted by the compiler. Out of the 16 bits, 1 bit is used for sign, and that is the most significant bit, MSB. And 15 bits are used for storing the value of the constant. So out of 16 bits, 15 bits are available to represent the int constant in binary form. Considering this, an int constant can have a value between minus 32768 to plus 32767. From where this number has come? It is simply 2 raised to 15. That comes to this number, and plus and minus sign is given as is present in the 2 bytes as a first MSB bit of the allotted 2 bytes. There are rules for constructing int constants. It should have at least 1 digit, it's very logical. It can have a positive or a negative sign. It should not contain any special character or symbol or decimal point. By default, if the sign is not specified, the value is taken as positive by the compiler. These 100, 3, 4, 6, 7, minus 4, 5, 6, etc. are all valid int constants. 0.123, 34 plus 56, 24a are all invalid because they do not follow the rule of constructing a int constant. Then there are type of float constants. A fractional constant is designated as a floating point constant and expressed with keywords float. Float is always representing a constant which is fractional. In C, we can represent this fractional constant either in the fractional form, that is with a decimal point, or in an exponential form, that is expressing it with a E, symbol E, or the letter E. These are all the legal float constants. Legal in the sense they are valid, they will be accepted by the compiler as constants, float constants, which are built as per the rules for building the float constants. We can see here 3.567 minus 12.12, 55.0. These are all legal and acceptable float constants. Then this is 3.14 e raised to 10 minus 23.714 e raised to minus 34. These are all accepted by compiler as valid float constants. Float constant can always be positive or negative, but default is taken as positive when no sign is mentioned. A float constant is allotted 4 bytes in the memory and can have values between 3.4 into 10 raised to minus 38 to 3.4 into 10 raised to plus 38. It's a huge value. A int constant gets 2 bytes, whereas a float constant gets 4 bytes. In exponential form, it is written as 5.6 e raised to 3, etc. Mantissa part and exponential part is separated by lowercase e or uppercase e. Rules are again the same. Float constant must have at least 1 digit, must have decimal point, or e must not contain any symbol, blank, or special character. When written in fractional form, it can contain a decimal point. When written in exponential form, it should contain a small case or a uppercase e. The third type of constants that are used is character constants. What are character constants? A single alphabet or a symbol or a digit is called char constant. Character constants are abbreviated as char constants. Char is a keyword. It occupies only 1 byte in memory. In C, a char constant is allotted only 1 byte in memory. The reason behind it that we will know as we proceed further with the presentation. There is a peculiar style by which we should write a char constant in our program. It should be enclosed in single quote, both pointing towards left. Unless we write the char constant in this fashion, compiler does not recognize it. It just throws an error while compiling the program. Now we can see here a capital letter or capital alphabet, a symbol like dollar, a symbol like semicolon are all char constants. The reason why char constant can be accommodated in 1 byte is a char is represented by a code called ASCII code. In this code, every character has been associated with a number, and there are 256 characters which are associated with 256 number in the ASCII code. When we press a key for capital A while inputting a data from keyboard into our program, or whenever it appears in the program, that A gets stored as number 65. B gets stored as 66, Z gets stored as 90, and so on. Let us consider a small snippet from some program. The program reads like this: float val char answer val is equal to 3.14 into 10 plus 20. Answer is equal to y, should be in the single quotes pointing towards left. Here there is a mistake in typing. It is pointing towards right, but it is wrong. It should be pointing towards left. When we are writing a snippet or when we are writing a program, when the constants appear in the program, we need not specify their type. In this small snippet, 3.14, 10, 20, y are all present as constants, but there is no need to specify their type. C compiler need not be informed about the data type of the constant used in the program. Why? Because compiler senses the type and allots memory accordingly. 4 bytes for float constant, 2 bytes for int, and 1 byte for char constant. When a program or when a statement contains only constants, then that expression is evaluated at compile time. It is not necessary to evaluate it. C compiler does it at the compile time and not at the run time. Now in this val is equal to 3.14 into 10 plus 20. This expression contains only the constants. So they will be evaluated, this expression will be evaluated at the time of compilation, and the value will get associated with a variable called float or called val. How constants are stored in the memory? Let us take a conceptual view. Let us consider the same snippet which we discussed earlier. As we know, a memory, every byte in the memory has a unique address. Now in this conceptual view, the address is shown here is 100 to 109, which doesn't mean that it should be the address every time. It is just an example. Each memory location is 1 byte, is of 1 byte. So a constant 3.14, which is a float constant, will be allotted 4 bytes in the memory, and the first byte will be 106. So 106, 7, 8 and 9, these 4 bytes will be allotted to store a float constant. 10 and 20 are int type of constants. Each will get 2 bytes in memory. The 10 is say stored in memory location 100 for 105, 20 is in 100 to 103. In 101, y being a char constant, it gets stored in location 101 as number 121, 121, because that is the ASCII code of y. As we learnt earlier, a character constant always gets stored or is always recognized by the ASCII code associated with it. We can know the ASCII code of all 256 characters from a ASCII table, which is very easily available anywhere. We are not going to show it here. All the constants, all the values are stored in the binary form. But what about val? Val, it is a variable. Where it gets stored, how it gets stored, that we will see when in the next few slides, when we will be discussing about variables in C. Variables are named memory locations. A memory location, up till now what we have seen for constants, is having a address. In variables, those addresses are associated with variable names, and they are created to hold values that change during program execution. As we have seen, constant value is always constant, it will never change. But there are many instances or in a program where the values of a particular program, the variable, the numbers in the program will keep on changing as per the program logic. To store such kind of values, variables are used and created. There is a requirement that a variable name and its data type must be declared at the beginning of the program. Not necessarily at the beginning, but before use, it is a must. It is a general practice in creating a C program where the variables are declared at the beginning. That is a general practice. We can declare it anywhere in the program. The only requirement is when you are going to use that variable, it must be first declared and then used. Variables hold different values assigned during program execution as per the program logic and user inputs. Now let us see a small program. It converts temperature entered in the centigrade into Fahrenheit scale. So again, hash include stdio.h. Sorry, there is a mistake here. Instead of this colon, it should be a quote. Void main v should be small. A void written in this fashion with the v being in large cap will not be recognized by the compiler. While transferring this program from the compiler or from the file in which it is created, all these mistakes happened. Sorry for that. Then there is a opening brace, then float centi and FR. These are the two variables we have declared in this program. Then there comes a statement enter temperature in centi, which will be displayed on the screen. The user will enter whatever temperature he wants to convert from centigrade scale to Fahrenheit scale. That entered value will be accepted by a function called scanf, a function which is again declared in stdio.h file. It is used for taking keyboard inputs, and then the program will calculate far is equal to centi into 9 by 5 plus 32. It is a simple formula, and that value which centi gets converted into far, that will be displayed on the screen by this statement, by this function printf. Now we can easily see that when this program is being used, distributed to the users, each user will have his own value to of temperature in centigrades, which he will like to convert into Fahrenheit value. So naturally, centi, this variable to which we are assigning the input from the keyboard, will always have different values. Value in centi varies as per the user input, and value of a far will vary as per the centi. Whatever is the value of centi is input by the user, far will be assigned by by converting centi by using this formula. So what we must understand is variables are used to hold values that change during the program execution. Even a single same person or a same user is using this program for conversion of centigrade to Fahrenheit. That's temperature in centigrade. He may wish different values for that. So if a variable will always be holding values that will be changing as per the requirements of the user, as per the expressions which are causing changes in the value of a variable. There are two types of variables called primary and secondary variables in C. A primary variable is one of the type int, float or char. Secondary variables we will see later on as we go ahead with our different videos on different topics. Variables stored in the variables, the values stored in the variables can vary during the program execution depending on the program logic and user inputs. A variable must be declared before its use in the program. Name of a variable must start with an alphabet or an underscore. It is a rule how to construct the name for a variable. No other symbols, blanks and commas are allowed while naming the variable. Name can be any combination of minimum 1 to maximum 31 number of alphabet digits and an underscore. X, capital X, small case A, ABC, mult, MULT, school underscore name, area underscore circle, underscore orange one are all valid names. They are built following the rules. Whereas one orange, 3 underscore area, orange and mango are not valid. Why? Because a variable name must start, the first alphabet in the variable name must be a alphabet or a underscore. Here 1 is not an alphabet. Same thing here, 3 is not an alphabet, so this is not a valid name. It will not be accepted as a valid name by the compiler. Orange and mango, the ampersand is a symbol which is not allowed to be used in the constructing a name for a variable. Let us understand the int variables through a simple program. Include stdio or .h, hash include. Hash is a must before include. Stdio.h is again the name of a file which is called a header file, which has been which contains the various input output functions which are already present in the file, which we can use in our programs. There are two variables, a small case and a capital. Small a is assigned with a value of 20, capital A is assigned with a value of minus 20. There is a third variable, int xyz. Xyz is the name of that variable. Now there is an expression, a mathematical expression. Xyz is equal to small a multiplied by capital A plus 100. There 100 is again a constant. 20, minus 20 and 100 are constants in this program. Small case a, large case a, x, y, z are names of the variables of type int. Is equal to sign, this symbol is the assignment operator. It is called an assignment operator. It assigns, by using this operator, the value that has been evaluated of the expression on the right of assignment operator will be assigned to a variable name on the named on the left hand side of the assignment operator. In this case, it is xyz. Then there is a normal printf statement where we want to display the value of small a, capital A, and finally the value of xyz after it is evaluated in this statement, in this arithmetic expression or a statement. Then the closing brace. Hash include is called a preprocessor directive. stdio.h is called a header file. It contains information of many predefined functions like printf, scanf and all. A small, A big, xyz are names given to variables declared of type int, assigned with values 20, minus 20. No value is assigned to xyz. At the compile time, xyz will not have any value. 100 is a constant of type int. C is a case sensitive language. It is important to note that C is a case sensitive language. A capital A and a small a are two different variables. They are treated as different by the compiler. Printf is a predefined function. On its execution, it outputs the text appearing between two quotes on the monitor screen. /n causes the text following it to appear on the new line. %d is called a format specifier. It tells the compiler that the variable appearing outside the quotes and after comma is of type int. Whenever a printf function gets executed, this %d will get replaced by the value the variable is holding. It will not appear as %d, but it will %d will be replaced by the value held by variable xyz in this case, or a or small a, etc. What this program will output: a is equal to 20, capital A is equal to minus 20, xyz is equal to minus 300. Is equal to operator is an assignment operator. It is called an assignment operator. How they will get stored in the memory? A will get stored as 20 because it has been assigned with value 20 and will be stored in 306 and 307 memory locations. XYZ gets a memory location at 302, 303, but at compile time, XYZ's memory location will not contain any value. It may be some random undefined value, which is always referred to as a garbage value in the parlance of C programming. So every int variable gets 2 bytes in memory and its value is getting stored in the memory. 306 is the address in which variable A's value is stored. In our program, we refer a variable by its name. We refer int A, int XYZ, and so on. Whatever variables we are using in the program, we name those variables. Compiler allots the memory location to the variable and associates its address with that name. What compiler does, it allots a memory location as soon as it comes across a variable at the time of declaration, and if it has been assigned value at the time of declaration, that value will get stored. So compiler allots memory location to the variable and it also associates its address with that name. So A gets associated with address 306. XYZ get associates with address memory location address 302. So we can say that variable is the name given to memory location. When we say A or XYZ, then we are actually giving 302 a name XYZ. Variables of type float hold fractional values. Its declaration is float ABC or float balance, etc. It gets 4 bytes in memory and thus can hold values between these 3.4 10 raised to minus 38 to 3.4 10 raised to plus 38. We can declare and assign a value to a to the variable at the declaration time only. Float A is equal to 23.45678, etc. These are all variable names, float type variable names, because we have written this as float. We have specified these variables as float. One important point we should know about variables is names is keywords cannot be used as variable names. We cannot use int float being a variable name, as it is a keyword. Then there are third type of variables, which are char variables. They are built to hold character constants. Every char constant has a unique ASCII code or ASCII value. That value was stored in the char variable. There are 256 characters that C can identify and use, or the compiler can recognize. A char variable gets 1 byte in memory and it can hold values between 0 and 255. So it covers all the characters that are defined in the ASCII code. Char cool, char summer, and so on can be the names of the variables. The way they are used for declaration as char cool, char summer, char ABC, whatever name you have to give, that can be given to a variable, except the keywords. When we use a char variable and try to assign a value to it, then it should be written with a within single quote, both pointing to left. Here what we are doing is a variable called pool is getting assigned with a value A. Here a char num is the name of the variable of char type getting assigned with a value small case b. Here it is getting example is equal char example is equal to 9. The digit 9 is getting assigned to a char variable named example. Char symbol is equal to, in single quotes, equal to sign, equal to symbol, that get assigned to a variable called symbol. Wherever the char constant appear in the program, or wherever a char constant are assigned to a variable, then it must be within the single quote, both pointing to left. That is very important, otherwise the compiler will not recognize those as valid variables and will throw out an error while compilation time. For a float variables in a program, it is a simple small program. We have declared x and y as float variable and the third float variable as zz. We can declare a variable of type float or any type of variable in one single line. Just the first variable should need to be declared as float. Then the name of the variables can appear in the same line with comma. No need to every time declare float x is equal to 4 this much, float y is equal to this much, float z is equal to this much, not necessary. Now this printf function or the printf statement output the values of x and y, because we are written x is equal to %f, y is equal to %f within the double quotes, then a comma, then the names of the variables. %f is the format specifier for a float type of constant or variable. A float, %f float or %f, when we use %f as a format specifier for putting the values of set of float variable to output screen, it will always appear with 6 digits after decimal point. Now this is here it is 20.0, but actual when it will appear as an output on the screen through the printf statement, then y will appear as 20.0000000, 6 digits after the decimal point. We can limit this number of digits after decimal point by putting a %1.2f as a format specifier. So this will limit the display of output to 2 digits after decimal point. These are the memory allotted to float variables. X gets some value, whatever has been assigned to it. Y stays in 4 bytes, whatever is the assigned value. In the beginning, at the time of compilation, ZZ will not have any value, it will contain all the garbage value. When ZZ gets a value evaluated by x plus y, when the x plus y expression gets evaluated, its value will be assigned to ZZ, and then that value will appear in the memory location. That value will be stored in the memory location. X and y are created at compile time, and ZZ is assigned with the value after the runtime, during the runtime of the program. Similarly, we can construct char variables and assign values to them. Char ABC is equal to s, x is equal to x, char xs is equal to 9, char sim is equal to %. Then we can, these are normal printf statements. This will dump the output held by the variable named after the comma onto the screen. The output of this is the screenshot of the output screen. ABC is equal to S, sim is equal to %, XL is equal to 9. Please ignore this underscore. The variables, char variables in the memory, XS value 9 stored in location 105 and so on. There are 32 keywords in C. These are int, float, char, if else, for, while, continue, break, switch, and many more. Total 32. Whenever the compiler encounters a keyword, it initiates a definite predefined action. A table of keywords can be found in the help section of IDE. We have seen int, float, char up till now. We have also discussed about void. The meaning and use of all other keywords here we will be dealing with further topics. Actually, learning programming is understanding how to use the variables, keywords and constants in logical way, in syntactically correct way. Then there is another variable which is an int type, but it is unsigned int. That means we are telling the compiler that whatever variable we are declaring, we will not have a signed value in it. It will be always a positive value. When we declare some int variable as or a int constant as unsigned, then the most significant bit of the 16-bit or 2-byte variable or the memory, when it gets 2 bytes in the memory, the 16 bits will all be available for a unsigned int. When we can use, when the number can never go negative, such as number of students in a class, there cannot be negative number of students, there cannot be negative fare in a train. So when we are going to use this kind of values which will never go negative, then we can use an unsigned int. The benefit is, instead of 32768 minus 2 plus 32767, we get a larger value to store. On declaring int as unsigned, its range is now 0 to 65535. It's simply the addition of minus 32768 and plus 32767, ignoring their signs. How it is declared? Unsigned int. Here it is unsigned. Before int we have to write unsigned. Unsigned is a keyword. For printf and scanf function, unsigned int format specifier is %u. For signed int, %d is the format specifier. For unsigned int, %u is the format specifier. We can use the unsigned int program. It is shown very simply in a very simple program. We have declared inventory as an unsigned int and assigned a value of 50,000 to it. Then there is another unsigned int variable declared num ordered. The program is asking user to enter the number of items to order, it gets associated with a variable num ordered in the scanf statement. %u is the format specifier for unsigned int. Inventory is equal to inventory minus num ordered, and that is the printf statement outputs the actual inventory after the ordered after the ordered quantity deleted from the inventory. There is unsigned char variables also can be declared. Then the 1 byte will contain values between 0 and 255. When it is not declared as unsigned, then 7 bits are available for decimal values between -128 to +167. When it is declared as an unsigned char, 0 to 255 will be the range which can be stored in a char variable. There are 256 ASCII characters, so each character, ASCII character, can be stored in one 8 bytes long char type data. A small program of unsigned char program where declared unsigned char UCH is equal to 0 and char CH is equal to 20. These two char CH is equal to 200. These two char type of variables have been declared. One is unsigned char, other is char. It is a signed char. Then we are asking user to input any number between 0 and 255. That number will be stored in the variable UCH. We are again asking user to input a ASCII. We are printing out, or we are outputting the character for ASCII UCH is equal to %d is %c. What this tells? First of all, whatever is the int value or whatever is the ASCII number that has been stored in UCH will be outputted as a %d form by %d format specifier, and %c format specifier will output the value stored in UCH in the form of a character. Here what we are doing, we have assigned a value of 200 to char CH. CH is a signed char type of variable, it cannot hold 200. What will be the output? That is interesting to see. We will see the output for each of these printf statement. First, enter any number between 0 and 255. The user has entered 78. %d causes UCH is equal to 78, and the corresponding character associated with ASCII code 78 is capital N. Then character for ASCII code CH is equal to -56. Now why this -56? Because CH has been assigned 200, which it cannot hold because it is a signed char variable. So what actually it will hold is the maximum value that it can hold, that will get subtracted from the assigned value of 200, and so the balance is -56. CH will always hold minus 56, and its character representing minus 56 is some symbol. Then character we have assigned 20, we have assigned 50 in this statement. CH assigned 50. We have in this statement UCH has been assigned with value 50, and 50 is a ASCII code for digit 2. In this way, all the characters and the assigned values or the ASCII codes of it will be outputted in this program. There are many useful build functions which we can use in our programming. CLR SCR, it clears the current screen of all text and positions the cursor to the left top of the screen. Its prototype is declared in header files conio.h that we will have to include in our program at the start. Another function that has been declared in getch, it is declared in conio.h again. The simply what it does is it reads a character directly from keyboard, but it does not echo it on screen. If it appears at the end of main, output screen is displayed. Otherwise, we have to key in Alt plus F5 to see the output screen. Exit 1 is the function which closes all the files and terminates the program. Its prototype is declared in stdlib.h. Then POW xy raises x to power of y square, sqrt is for taking square root. These are all defined in math.h. In my next video, it will be on arithmetic expressions. In next few days, I'll be uploading videos on if, else, switch, pointers, functions, and so on, up to graphics. Please keep watching for the videos and like, subscribe, and share. Comments are always welcome. Thank you very much for watching. Thanks.